Hey guys, so one of the things I'm getting questions about is impulse momentum, and specifically just really understanding that the relationships between all the elements of that equation. So one of the questions I got specifically, which by the way, thank you for sending me a specific question to answer instead of just like, what is impulse momentum? Very helpful if I can direct my responses, was about this problem here. Okay, and this problem is really designed to help show the relationships between all the elements of the equation. So first thing I'm going to do is I'm just going to rewrite the equation, and that is that impulse is equal to force times change in time, which is equal to mass times change in velocity, which is equal to a change in momentum. So again, as I've mentioned before in some other videos, you can set any of these two things equal to each other because they're all equal to each other. If A equals B and B equals C, A also equals C. So you can set a whole multitude of relationships through this. So I'm just going to leave that off to the side here. Now, we've got a baseball being hit with or being thrown by a pitcher, I think. Yes. And so it says, draw a picture. And so picture's important because it's going to set up your directionality. Because remember, force and velocity are both vectors. So we do care about direction. So I'm just going to have mine being thrown to the right. So I know that, let's see, I've got the mass of 0.14 kilograms. I have a force of 132 newtons. And I know that there's the force is being applied for a period of 0.045 seconds. Okay, so that's all the information that I know. And it says, what's the impulse applied to the ball by the pitcher? So impulse, that's our J. Okay, so then it's really a matter of, what information have I been given? As we can see, as I will note in a different color here, we have been given a force, we've been given a time, and we've been given a mass. So if I want to know the impulse, well, impulse, that's my J. So that equals force times change in time. And because it's equal to force times change in time, I know all that stuff. I have it up here. So I can get just a quick equation here. Force was 132 newtons times 0.045 seconds. And so then I end up with an impulse applied of 5.94 kilogram meters per second. Now I could have also written, because it's force times time, I could have also said 5.94 Newton seconds. Those two are equivalent. So those sets of units are equivalent to each other. So a kilogram meter per second is equal to Newton second. So either one, totally fine answer. So that's the impulse applied. Now this next one, let's just keep going with this colors things. Yay, helps brighten the day. Considering it's snowing in April. Just I had to bring that out there. That's snowing in April, so I'm getting my holiday wish list together. See if I can trick the family into putting up the holiday tree and all that stuff. So anyways, we want to know change of momentum. Well, if I go back to my equation, here's change of momentum right here. And I know impulse, I know force times change in time. So I really could set up either of these equations right here. I could say that change momentum is equal to impulse, or I could say change in momentum is equal to force times change in time. Either of those options are available to me. Now I just solved for my impulse, and I have technically also solved for those, and since they're equal to each other, I could redo the math and say, well, that force is 132 times 0.045, or I could just say, yeah, I solved for that, so I'm just going to bring that down here. So therefore, change in momentum is equal to 5.94 Newton seconds, or again, 5.94 kilogram meters per second. Either would have been fine, totally good. All right, so, again, it has to do with how well do you actually understand this equation gives you the flexibility to set so many different things equal to each other, which is one of the reasons why it confuses many students. They're so used to an equation where it's just like, this equals that, end of story. Here it says, well, what's the information you were given? And then based on that information, what do you want to find? And so you've got to do a little more digging, a little more clarity in your setup. That's why I've been kind of marking these in different colors here. The last question here, which you can't fully see, and I'm just going to scroll down a little bit. There we go, perfect. It says, assuming the ball is at rest, it's supposed to have a different color here. Green, I have not used green. My two gaming buddies' favorite colors to always be. I don't get it. I'm a red guy myself. But so is my son, so we fight over it all the time. Oh well, I let him have it because I'm an adult. I let him have it half the time, let's be honest. All right, so assuming the ball is at rest, so that would be my initial velocity. When the force above begins to act on it, what will its speed be when it leaves the pitcher's hands? So we want to know after it leaves the pitcher's hands, what we're really looking for is that final velocity. Okay, so if we have a knowledge of initial velocity, so I could almost add that to my information up here. Let's say my initial velocity is 0, and we're looking for a final velocity. Well, then that's change in velocity. So now we can pick whatever we want to set equal to whatever we want. All right. So I could set my impulse as equal to mass times change in velocity. I could go back to the original set of information, say force times change in time is equal to mass times change in velocity. Or I could use my knowledge from part C and say change momentum is equal to change in velocity. Either of those choices are all good. So let's just scroll down a little bit here so we got some room to work. So if I'm going to go through this, then I can really just say, hey, impulse is equal to force change in time, mass change in velocity, and all that's also equal to change momentum. Well, we know for a fact that all of these are 5.94. So really, we have 5.94 equals mass times change in velocity. And whenever you do change in velocity, it's always your final velocity minus your initial velocity, which we know is at rest, so our initial velocity is 0. So we can put that in there. So really what we've got for our math is 5.94 is equal to the mass of the ball, which is 0.14 kilograms, times this final velocity, because again, that's 0, so it just kind of nukes out. So we can crunch the numbers, and we get a final velocity of 42.42 meters per second. All right. So again, I've mentioned it a few times, but the big thing about this impulse momentum theorem is it sets so many things equal to each other, it just gives you a lot of options. And so making that good list of givens, making a nice clear picture, that's going to be what's going to help you out the most in solving these problems. So thanks for the question. Hope that answered it. Hope that helped with your impulse momentum woes. And I'll be back next time with another video. So yeah, keep those questions coming.